Okay, so we have our series here. It's really a geometric series. What we're trying to find out is if this thing is, what's its, where it works, essentially. Like where it converges. Where it converges. So the way we find out where it converges is by first noticing that it's actually a geometric series. And by where it works, I mean that wherever x leads to convergence. As you can see, we never had an x in there before. We never had another variable. With this one, we're trying to find for what variables, values, does it actually converge. And so it's not so difficult. We have a geometric series, and we know exponent properties. So negative 5x to the n is the same thing as that. So this would be our series from n equals 1 to infinity. And now we could go ahead and notice what's our r. Our r is negative 5x. And we know stuff about r, right? Like this is r, and we know that if the absolute value of r is less than 1, it converges. R is negative 5x in our case. So if if the absolute value of negative 5x is less than 1, that's going to converge. So the way we do this is with negative 5x is less than 1 and greater than negative 1. Because that's just how we do absolute values. We take the negative version of whatever we have here, and that's going to be on this side of the alligator mouths there. So I know it's been a long time, but that's how it went. And we divide now by negative 5 in order to solve for x. This is positive 5. Remember, with these things, we're taking the absolute value. It's obviously going to be positive 5. So this is negative 1/5. And so that's what our value for x is. And so then we call our radius of convergence 1/5. 1/5 becomes our radius of convergence. Radius of convergence. Why do we call it a radius? Because it's think of like a circle where you have a radius and then you have the other side to make the diameter, right? It's the same. We've got 1/5 and then negative 1/5. But it's the same absolute distance there. So that's what that is. The radius of convergence is 1/5. And so then the entire interval of convergence, which is what we were really looking for, which is what is more important, the interval of convergence would be when x is an element of negative 1/5 to 1/5. And these are in brackets because it has to be in between them. Remember, we have to be less than 1 in order to converge, not less than or equal to 1. So that's it. We have it, and what would it sum to? What would it actually sum to? That's a further question we might ask. I don't know if that's actually being asked by the book, but what would it sum to? Well, we have our formula, a over 1 minus r. A would be our first term that we plug in. So if we plugged in 1 over there, we would just get negative 5x. Negative 5x. And r, we know, is also negative 5x. So that would give us plus 5x. And so that would be how we would get our sum. And we could plug any of these values in between there, and all of those would converge to a sum of that form.